Now we are going to take up one more problem on shaft, the problem number 31. It reads as a solid shaft is required to transmit 112.5 kilowatt power at 150 rpm. The diameter of the shaft is 100 mm and length is 10-meter long. Determine the maximum intensity of shear stress and the angle of twist. Take G equals 82 GPa. This has been asked in June-July 2019. So now we are going to analyze this problem. What are all the data given? So as he has given, the solid shaft is required to transmit 112.5 kilowatt power. So power is given. Capital N is 112.5 kilowatt. And at 150 RPM, so small n will be equal to 150 RPM. So he has given the diameter of the shaft, which is 100 mm, and length is 10 meters, which will be equal to 10 into 10 to the power of 3 mm. So there, determine the maximum intensity of shear stress, that is tau equals question mark, and take G, and also the angle of twist, which is theta, which is to be found out, and take G is equal to 82 GPa, which is 82 into 10 to the power of 3 Newton per mm square. So first we are going to find out what is the power transmitted by the shaft, that is torque we need to find out. Capital N will be equal to 2 pi N into T by 60,000 kilowatt. So substitute the values of capital N and small n to find out torque. So that is 112.5 will be equal to 2 pi into 150 into T by 60,000. Therefore, T will be equal to 7161.97 Newton meter. So the torque transmitted by the shaft, capital T, will be equal to 7161.97 into 10 to the power of 3 Newton mm. So to convert meter into mm, multiply by 10 to the power of 3. Now from the strength criterion, we have T by Jp, which is equal to tau by R, which is equal to G into theta by L. So consider only T by Jp, which will be equal to tau by R. So substitute the values, 7161.97 into 10 to the power of 3 divided by pi into 100 to the power of 4 by 32 will be equal to tau divided by 100 by 2. So on further simplification, what you will going to get it is 7161.97 into 10 to the power of 3 into 32. That is, this will go to the numerator into 32 into 50, because 100 by 2 is 50. It will be equal to tau into pi into 100 to the power of 4. Therefore, the maximum intensity of shear stress tau will be equal to 36.47 Newton per mm square. So consider the rigidity criterion, which will be equal to T by Jp will be equal to G into theta by L. So substitute the values now. 7161.97 into 10 to the power of 3 divided by pi into 100 to the power of 4 divided by 32 will be equal to G, 82 into 10 to the power of 3 into theta by L, 10 meters, that is 10 into 10 to the power of 3. So therefore, angle of twist. So to find out that, you just cross multiply, that is 7161.97 into 10 to the power of 3 into 10 into 10 to the power of 3 into 32, because this 32 go to the numerator. So that divided by pi into 100 to the power of 4 into 82 into 10 to the power of 3. On simplification, you will going to get theta in terms of radians, which is equal to 0.0889 radians. So convert that radians into degrees. So to do that, theta will be equal to 0.0889 into 180 by pi, which will be equal to 5.097 degrees. So this is how you will be able to analyze and solve this particular problem. Thank you.